Let's talk about MATLAB and what are effects you would never expect if you use a professional tool like MATLAB when solving an equation. What can happen? I will show you very astonishing things, and my wish is never forget these, because then you can really understand what are the limits of numerical solvers. Okay, the command in MATLAB is F0 to solve an equation, to find the solution of an equation, or better, to find the root. If it's not a is equal to 0 equation, then bring the right hand side by a minus to the left hand side, and then on the right hand side you will have an equal to 0, and then use this left hand side and tell MATLAB, please find the 0 of this function. What is inside of the algorithm you can check by type F0 or edit F0. I did that, and it's a long block of code, a lot of error handling, but I will show you the core, the mathematical core on top, and there you will find bisection is a thing which is used by F0, the secant method, or something like the secant method, and a more sophisticated secant method, which is inverse quadratic interpolation. And you can give MATLAB, you can pass a starting point, or alternatively you can pass a starting interval, and then in this interval you are looking for the 0. Okay, if you provide not an interval but only a point, MATLAB by himself will find an interval. That's the first step of the logic. Find an interval, and the function value at the left hand side and the right hand side is of different sign. That's what will happen internally. And here I copied line 450 till 470, and this is original MATLAB, and you see the word bisection, you see linear interpolation. What is secant method? I wonder why there is not the word secant. I think it's secant, and inverse quadratic interpolation. The details are very good hidden in the code. I did not do the work to understand every single line and the reason for every single line, how it's formulated. But the core are bisection, secant method, and one more thing. And this one more thing, what is that? Okay, what is the idea of inverse quadratic interpolation? So what is the idea of quadratic interpolation? If you have not only 2 points and then finding the secant and then finding the root of the secant, you can also use 3 points. Evaluate the function at these 3 points, find a degree 2 polynomial interpolating these 3 points, and then find the root of this parabola. And there is a formula, we call it ABC formula in Germany, or the midnight formula. You can find the root of such an degree 2 polynomial. Okay, and what is that? This is secant method, but one order higher, so it is obviously not the worst idea to do that. But this is not the inverse quadratic interpolation. Now we will talk about inverse quadratic interpolation. And the idea is swap the axis. So say this is the argument, so it's maybe a polynomial with the letter y instead of x, and then take these 3 points and interpolate these 3 points by a degree 2 polynomial, and the variable is a y, and then find the root the root corresponds to the function value at position x. And this is the inverse quadratic interpolation. I did not spend too much effort to really understand the principle. Why is that better than the quadratic interpolation? Okay, but this is the principal idea, but I can't tell you why it's better or why it's not better. Okay, and again we have a secant method of higher order, and that's what's going on internally in F0 bisection secant or this inverse quadratic interpolation. So it's not hard to understand the idea beneath the surface. Okay, so we understood that, and now let's demonstrate what happens if you, being a user, are calling this F0 command, and I in my personal life was surprised from time to time, and now we will talk about that. If we take the sine function, we know the roots. What is the sine function? This one, this is position 0, this is pi, 2 pi, 3 pi, 4 pi, and so on. These are the roots. And 500 times pi is also a root of that function, is also a position where the function value is 0. And if we call F0, we go to 500 times pi. This is more or less 1500. And a little next, we start a little next to that, we will find this position because the deviation is 10 to the power of minus 13, which means we found that 0. But now let's exchange 500 by 5000 and let's do everything as we did before. Again, go to this position very close next to this position, and then we will find something by calling F0, and taking the difference should be a 0 or a numerical 0, but it is not. It's minus pi, which means that the root, we started very close to this root, but we found that root. And this is very astonishing. We started very close to a root and we found a root, but the wrong one. The one which was not close to the initial value, but away from that. And this is a very, very big surprise. And I was surprised. I did not try to find the roots of sine, but a function which is of the same type. And this had to do, I wanted to calculate the point of time when the sun rises and the sun sets, and then I had exactly that problem because I did it for a whole year, and then more or less we had that situation. Wrong root. Although we started very close to a root, we found not the root close to this initial value. The reason is MATLAB, if you provide only one starting point, MATLAB by himself will find a second point where the function values are of different sign, and then in this interval you are looking for the solutions, and then there are many of them, and then our algorithm will find one of them, and which one is more or less coincidence, and in this case the wrong one is found, and that's the situation. Okay, you can also check the code. I found in the code where this happens, where on top to the starting value a second one is determined. But there is a remedy. If you call F0 as we did here, but not a starting point but an starting interval, this interval has to be of the type one function value positive and one function value negative, only that is allowed, otherwise you get an error message, then MATLAB will never leave this interval, and so in this case it's guaranteed to find the solution we are really looking for. So we again see the professional MATLAB, you need initial guess where is the root, and then MATLAB will refine that guess. But the hope, I have no idea of nothing, and MATLAB will help to solve every problem. This is not true. Okay. Then a second example we already saw is the rope around the world. And if we start our algorithm in the following way, although being close to the solution, we will find not the one closest to this initial point, but another one. And in this case, the angle is 2, which is more than pi divided by 4. So this is a nonsense solution in the context of our rope around the world. But it's a solution of that equation. So the wrong one is found, but there's a remedy. Tell him, please only check the interval between 0 and pi divided by 4, which means these angles. Here is pi divided by 2. And then you will find the one you are looking for. Okay, so it's always better to use F0 with an interval. In Python there's a brand-Q algorithm, and then it's better to use this one. There you also have to provide an interval, and if you are able to provide that, this is the better choice. Okay, so please never forget that. And then a very important remark again, if you have the following situation, it's a function and heavily oscillating, and if you have the following situation and then you have no root, or if you have the situation that in this interval we have 2 roots, and if we focus to that part, then we see that one, there are 2 roots, it's almost impossible to find this or these 2 roots. If you know the function is of that type and there are 2 roots, then okay, then everything is fine. But if you don't know, how can you find these 2 roots and be sure never miss these 2 roots? And this is numerically impossible. Okay? If you have an interval 0 to 1000 and only in this small part the function value is negative, and then there are 2 roots, how can you find that these 2 roots? If you evaluate the function left and right and they are positive, and then you check maybe some intermediate values and they are also positive, then assumption is function is positive, there is no root. But how can you formulate an algorithm to never miss roots in this situation? And the answer is this is more or less impossible. You can always evaluate the function at very, very many points, and then you can hope that you will notice the change of sign of the function value. But in this situation, it is not enough to evaluate at 1001 points. If you evaluate here 2000 points, you again will miss these roots. But if you evaluate at 20,000 points in this situation, you are able to find these 2 roots. But that means that for a function where there is no solution, you always would evaluate before telling, oh, I can't find, evaluate at 20,000 points, and that would be a very, very slow algorithm, so you can't formulate it in that way. And if the interval is smaller, then you need to evaluate at 2 million points, and this is the story. So never try to formulate an algorithm which is able to never miss a solution, and never hope there is an algorithm in your brilliant software tool which is able to never miss a solution. This is impossible, but this is unsatisfying. Normal expectation is mathematicians are great, they have great ideas, and they will do their job, and then my life is very easy. Okay, this is the story.